are able to find it, well and good. Otherwise, inform me. I'll try to search and send it again.
Okay, sir.
Okay. Then, Manan, turn on your camera. Srilasya, please turn on the camera. And if is there anything, we are today we are continuing with the magnetic effect of electric current. Okay, and this is the last topic that we are continuing. So, any doubts? Anything you would like to ask? You can just speak up at any time during the class. You don't need to take that permission or don't wait for it. Just you can ask at any time. Unmute yourself and ask your doubt. Okay, this is the procedure, right? So let's see. In the last class, we had seen that there are two types of wire which are running. That is, you have a live wire and a neutral wire. Okay, it is the live wire which carries the current, and it is the neutral wire which is there just for completing the circuit. The neutral wire is there for the circuit completion. The first thing that is connected at our home is the energy meter. You have your energy meter which is just outside your home. So your energy meter, it is the one which is connected to all the connection first enters your energy meter, right? So it enters your energy meter, and from here you obtain your, after this it passes on to the main switch. Okay. So after this, from your energy meter, this is your meter display, and from here you obtain the connection for the main switch, or this is also called as distribution box. Okay. But in the distribution box, you have the first connection being given to a fuse. Remember, the fuse is also connected in the, this is connected with the, you will have a fuse, and after that your connection will go on. So then here you will have a device, that's fuse. A fuse will be there. And then you can have different devices being attached. So how are those devices connected? In series or in parallel? How do we connect all the devices?
Parallel, sir.
Yeah, all the devices, they are connected in parallel. So what is the reason behind connecting them in parallel?
Can I say so?
Yes.
So it is because voltage is distributed when it is connected in parallel, sir. And
Now,
current is the same throughout the circuit.
isn't it something opposite?
Right, sir. Yes, sir. Voltage stays the same all the time, and current is distributed, sir.
Yeah, in the parallel circuit, whenever you have
Sir,
a
I
parallel,
meant that only, sir, but I was telling the wrong thing, sir.
yeah. So here you have the switch. From the switch, you have your whatever device or appliance is to be connected. So we can mark the appliance by resistance. Okay. I shouldn't have used this. I should have used black. So this is how your different devices. These are your device D1, device D2. This is your device D3. So all the devices, they are connected with the switch, and also there is a, you will also find here an earth connection. The heavy devices, they are connected to the earth connection. They are provided with the earth connection. Okay. So all the heavy devices which may be there, they are connected to the earth line. The devices which use heavy power, they are connected to earth, and the earth is earthed like this in the ground. It is ground with the help of a copper plate. So this is the earth wire. Now see, mainly what we are looking forward. First of all the connections they are made in parallel, and there are two things that it is easy to control them. If the devices are connected in parallel, it's easy to control them. We need not run all the devices at the same time. However, if they are connected in series, so all the devices would require to be connected in the same at the same time. Okay. Then in the parallel combination, it's easy to operate. Voltage remains same. So here voltage remains same. Current is distributed and easy to operate in the parallel connection. Okay, so these are the things that we are looking for in the parallel combination that we obtain.
Sir, what do you exactly mean like by easy operation, sir?
By easy operation means just we saw in the case of series combination. Okay, over there if you have to run a bulb, so you have to switch on all the appliances.
Right, sir. Okay, sir.
So that is what I mean. Okay, so someone sent the question paper, the question fifth. As we move away from a current carrying conductor, the space between the magnetic field lines of force. This is your question number 5, which was given in the question paper.
It will decrease, right, sir? Because the
Let
strength
me,
of the magnetic field lines will decrease.
yeah, but it's because the strength of the magnetic field line will decrease. Okay, so who had this doubt?
Sir, me, sir, Manan.
Okay, Manan. So let's see. First, clarify your doubt. So this is the question. As we move away from a current carrying conductor, the spacing between the magnetic lines of force will it increase, will it decrease, or will it remain at equal distances? So this was your option, and this was your question. So as we see, let's say suppose this is your wire, it's carrying current. So if you observe the current is in the form of concentric circles, right?
Yes, sir.
Okay. And as we move away from the wire, the magnetic field decreases. The magnetic field is stronger near the wire and weaker away from the field, away from the wire.
Sir, with the
Uh,
spacing between the magnetic
mm,
lines of force that are given, that is increasing, right? So isn't that the question?
The it says what will it increase or decrease? What will happen to the spacing between them? Okay. So the you have if you study the third point of the magnetic field lines, where we studied the properties of the magnetic field lines, the third point, it tells that the relative closeness of the magnetic field lines, relative closeness of field lines represent strength, right? Do you remember the third point?
Yes, sir.
It represents the strength of the magnetic field. So if the magnetic field lines are closer, then it means the field is stronger. If the magnetic field lines are far apart, it means the field is weaker. Okay. So near the wire, field is strong, and away from the wire, field is weak. So therefore, away from the wire, the magnet, there will be more distance, more spacing between the lines. Okay.
So
So
then
space,
increases will be the right answer, right? Because the space
yeah,
is increasing.
yeah. So it should be the right answer.
right, okay.
Okay. So it should
Okay,
be the
sir.
spacing between the magnetic field lines of force, they increase. Okay.
Okay, sir.
This is uh, so who is this? I think the question is discussed. Is there anyone who needs solution? Okay, so you can assume that this was maybe a wrong point that you have got. Okay.
Okay, sir.
Sir,
Yeah.
sir, can we like do more questions on like Fleming's left hand rule, sir?
Definitely, I'll be giving you in this test on the coming Sunday. You will get a subjective test.
Yes, sir.
Okay. So you'll get a subjective test in the coming test.
Sir,
Yeah.
my post-mid exams
Which
will
one?
start from 15th November.
Yeah.
Post-mid exams will start from 15th November, and we have electricity in physics.
Hmm.
Do you mind sending a few extra questions related to electricity?
If you want any chapter, no, any chapter question answers, I'll be sending it right in the group, and anyone can practice that. Okay, so in the group you will find by today night or by tomorrow you will find those questions from
Thank you, sir.
electricity. Okay, you can practice them.
Yes, sir.
Then okay, let's see the next one. We were doing the fuse wire over here. See what happens. We have two situations. The situations, one of the situation is called as a short circuit. Okay. So see why we are using all of them. So safety devices, they work during short circuit and overloading. So what is short circuit and overloading?
When there's a small fault in the circuit.
Okay. Okay, anyone else can try? What is short circuit? Anyone else who can, anyone can try out. What is short circuit? See, the word short means, it means short, okay, small. So short circuit, what it means? See, in this, the current is being carried in the live wire. Okay, current is being carried in the live wire. So here the current is flowing. And this part, neutral wire, it is there. It is there for maintaining the flow of current. Maintaining the current, that means it's over there just to see that the circuit is complete. Now, what will happen? See, when the current is flowing through this device D1, this device has some resistance, and therefore some work is being done by the current in flowing through this resistance. Okay.
Yes, sir.
So what will happen if suppose this neutral wire, it comes in direct contact with the live wire. Bypassing this device. Suppose the device is there, but there is a secondary connection which may be established between the live wire and the neutral wire. So what will happen then? Then since the resistance of this wire is less, so therefore current will now flow through this wire more heavily rather than the device. The current will not flow through the device and it will continue to flow through this wire
As there is no resistance, right, sir?
as there is no resistance, and also we know that the current is equals to V by R. Okay, even if you suppose that this device has a resistance of 100 ohm, had a resistance of 100 ohm, but the resistance of a copper wire which we are using, it will be very less. It may be 0.001 ohm. Okay, so there will be a heavy increase of current as current is inversely proportional to resistance. Since here the resistance has decreased, it has become almost zero. So therefore there will be a heavy increase in the current. Okay, so there will be a heavy increase in current and hence the current will increase. Okay, so if the current increases heavily in the circuit, as we know that the heating effect is equals to I squared RT. The heat energy produced in a wire is given by I squared RT. So if current increases heavily, the heat produced will increase much more. It will be square times. So if the current is increased 9 times, the heat will increase 81 times. So a lot of heat will be generated in this wire, which will cause the insulations to melt and hence the charges to jump out of the wire, causing electrical fires. So what happens during short circuit? During short circuit, the resistance of the circuit decreases. Therefore, there is a heavy increase in the current. When the current increases heavily, then there is a lot of heating effect in the wire, which will cause electrical fires. Okay. So I hope everyone has understood what is short circuiting.
Yes, sir.
Okay. So everyone has understood about the short circuiting. Now let's see the second one, that is overloading. What it mean by overloading? Overloading, it is a similar situation like this short circuiting. Okay. It is a similar one. Even during the overloading also, the current in the circuit increases heavily. Okay. But how much does it increase? Let's say. So during overloading, suppose there was a plug used by a device. Okay. So if you think of at your home different devices, there are a number of devices which have thin wires, which are connected with thinner wires. And there are some devices which are connected with thicker wires. Okay. So the thicker wires, they are designed to carry large amount of current, and thinner wires, they are designed to carry small amount of current. Okay, so if suppose you plug in a device which has a high power rating, that means it would require a higher current. Okay, so more amount of current will start flowing in the circuit as it is rated for. Every circuit has a rating. So this circuit has some rating that we can allow through this wire. Let us suppose I can allow through this wire a current of 5 amperes. Suppose 5 ampere current is allowed. Now, if I attach a heavy device over here, so a heavy device, it will have a low resistance and it will have a more requirement of current. It will have a requirement of current, let's say 10 ampere. Only this device has a requirement of 10 ampere. Other devices are also using the current. So there is a heavy increase in the amount of current. Okay. And again, we will reach the same situation. The wire will heat up. Okay. And it will cause electrical fires. So the situation will again become the same. So these are the two conditions which we meet with: short circuiting and overloading. So I hope you have understood the differences. What is short circuiting and what is overloading? Short circuiting means making the circuit short or small. Okay. Now we will see why are we using the fuse wire and why are we using the earth wire. Both of them, they are safety devices. The fuse wire is also a safety device, and the earth wire is also a safety device. Fuse wire is also a safety device. Earth wire is also a safety device. So what happens with the earth wire and what happens with the fuse wire? Okay. So as we can see, our fuse wire, it is connected in the phase wire or live wire. Okay. So fuse is connected in the live wire. This is the fuse. It's connected in the live wire in series with the live wire. Okay. It has low melting point. fuse will have a low melting point. So if the current in the circuit increases heavily, so in that situation, the fuse wire will break, the fuse wire will melt because of the heat generated in this fuse wire. The fuse wire will melt, causing the circuit to break. Okay, so the circuit will break over here. Silasya, Gundumela, Hasnita, Tanishka,
Yes, sir.
Dhruv, Veera Harshit, K. Subha Charvik, all your cameras are off. Saryu, Dhanunjay, why the cameras are off, everyone?
Yes, sir, on.
Everyone make your camera on. Manan?
Yes, sir.
Okay. So Manan, your doubt was cleared?
Yes, sir, it was clear.
Okay. See, the doubt is actually it's over there. We just saw that we discussed the right answer also. The right answer was it will increase. The spacing will increase, right? So don't get confused. You got it right, but there was some mistake over there, right?
Okay, sir.
Now see this question. Which one? Okay. Short circuiting and overloading. This you will write on your own. This is your homework. You can write your homework. Write the difference between short circuit and overloading. Or what do you mean by short circuiting and overloading? Then, okay, so short circuit and overloading. Then, what is the use of earth wire? Shravani, Tanishka, your cameras are on.
Sir,
Yes, sir, turning
Shravani?
it on.
Okay. So what is the use of the earth wire? See, all the devices which have a high power rating. Earth wire, it's not necessary for the devices which are using low current or low power. Earth wire, it is necessary for devices having high current. So it is necessary for devices using high current. So if any device which is using a high current, it requires to use the earth wire. Okay. So what is the use of earth wire? It carries the leakage current to earth. We will see what is the leakage current. It carries leakage current. Leakage current to earth. So what is leakage current? Suppose you are using an electric iron. Okay. So if you see an electric iron, it's something like this. Okay. So the body of the electric iron, and suppose it's connected with the two wires. The two wires it's just connected with two wires. There is no earth wire in this. Okay. So just the two wires. Now when the current starts flowing in the coil, it has a heating coil inside it. So when the current will start flowing in the wire, the body of the surface, the metal body of this device, there will be some charges which will jump out of the wire, which will jump out of the coil, and they will reach the body of the surface, body of the device. Okay, the charges which reach the body of the device, they will change the voltage of the device, and hence they can provide a shock to you. If you touch the body of the device, you will get shocked. Okay, so the earth wire, it carries the leakage current from the device to the earth. If you connect here an earth wire, the earth wire is connected to the body of the device, and it will carry this current to the earth, ground it. bypass all the current which is being leaked out to the metal body.
So I did not understand why do we exactly call it as earth wire, sir?
We call it as earth wire as you do not need to get it to your poles. They are not on the poles. You need to implement it on your own for your house. Okay. So
So we
after,
can directly connect our earth wire to the ground, and that's
yeah,
all,
it
sir.
is connected directly to the ground. So just nearby your house, somewhere behind it where the place is not less big, place is less visited. So earth is dug out, and inside it a copper plate is laid out. Okay, a copper plate with some area is laid out, and that copper plate is connected to the earth wire. So whatever leakage current passes, it will pass on through this copper plate to the earth. The earth will keep on absorbing that current, and hence you will be safe from any shock.
Yes, sir.
Okay. So that is why we call it as earth wire. And it is connected to the earth. It is not available on the poles. On the poles, you just have those two wires, the live wire and the neutral wire. Okay. So, okay, nowadays, instead of fuse wire, we are using or better relying on the MCB. Okay. The MCBs, they are based on the magnetic effect of electric current. Okay. Any other?
MCBs are those which, right, sir, which like we directly find in the home, sir.
Yeah,
They
at
just
your
turn off
home.
and turn on.
Yeah, suppose if at your home sometimes there is overloading. Okay, you use a heavy device, so the MCB trips off.
Okay, okay, sir.
Okay, so MCB trips off. That means the supply is cut off, and then you can turn off the device. You can turn on the switch. Okay, but instead of MCB, had it been the fuse wire, if it was a fuse wire, so once that fuse wire bent, then you need a technician to implement another fuse wire. You can't just go and keep the switch on.
Yes, sir.
Okay. So with this, we have completed this chapter. If anyone has any doubts regarding any topic, can ask. Otherwise, we'll be starting the new chapter.
Sir,
Yes.
sir, since I was unable to attend the classes due to my trip,
Mhm.
I have a few doubts in a few topics.
Okay. So just speak up your doubts, or if they are questions, so you can send
They're
or show
not
it in the
they're not questions, sir. They're topics. Like
Mhm.
a few. I didn't understand magnetic field due to a current in solenoid. And
Magnetic field due to a current in a solenoid. So have you
yes,
understood the magnetic field due to a single wire, single loop?
everything is like blurry. So I'm clear at till magnetic field and magnetic lines,
Mhm.
and then I'll have to get my confusion out. So my question is, if I have any doubts in any topic, can I like ask you in the
See, if
next
you have
session?
any doubts, that can be cleared. And if you want any topic to be done again, so I would better suggest you go and you will find a lecture with that name.
Sir?
You will in the resources section, you will find a lecture with the name where you will
Okay.
find that video lecture. You can look for it. And even if you are having finding any doubts, you have not been able to understand that, then we'll clarify it again.
Yes, sir.
Okay, so in the resources section, you will find it, the recorded video of
Okay,
that
sir.
class, and it will wear the same name. So you can either look for magnetic effect lecture 3 or 4, it will be where you will find it.
Yes, sir.
Okay. So if it's not there, I'll try to rename it and provide it. It will be available by the name today.
Okay, sir.
Okay. So any other doubt? Okay. I think, see, from this chapter, the questions basically arise relating to direction. Okay, what are regarding the directions of the magnetic field. Okay. So let's start with the new topic. The new topic which we should start. Shall we start with light?
So light is already done.
Yes.
Already
yes.
done. So any other chapter?
Carbon and its compounds.
Yes, sir. Can we do carbon and its compounds?
Okay, let's start with carbon and its compounds. So let's start with carbon and its compounds. Okay. So first we will see carbon, its role, how it exists in nature, and then we will discuss about the compounds of carbon. Okay. So if you see carbon, let's see how it exists. So carbon is an atom with a nucleus of 6 protons and 6 neutrons, right?
Yes, sir.
Okay. It has 2 shells. So like this. At the center, it has a nucleus, and the nucleus has, this is the central nucleus. It has 6 neutrons and 6 protons, right? Similarly, the electrons, there are 2 in the inner shell and there are 4 in the outer shell. These are the 4 electrons which are there in the outer shell. Okay. So if you see carbon, overall carbon has atomic number. So what is the atomic number of carbon?
6.
6. And what is its atomic mass?
12.
12.
12 something.
Atomic mass is 12. Okay. What is the number of electrons?
6.
6. Electronic configuration?
2.
2, 4.
Okay. Electronic configuration is 2, 4. Right. Now, this atomic mass can vary as there are certain isotopes of carbon. If you can see, we have certain isotopes of carbon, and they are, you will find your carbon 12, you will find your carbon 13, you will find your carbon 14. So these are the isotopes of carbon which exist. Carbon 13 and carbon 14, they are radioactive. Carbon 12 is not radioactive. The most versatile form of carbon is your carbon 12. Okay. Mostly we find carbon 12 around us. So why we are studying about carbon? The reason why we move to study carbon. Sri Lasya, are you understanding? Saryu?
Yes, sir.
Okay. So see, why are we studying carbon? Is there any specific reason why we are going to study carbon? The reason being that if you look in your body, so in your body you have carbohydrates, your body has proteins and your body has fats, right? So carbohydrates, proteins, and fats, this is what your body is made up of. Okay. And all these carbohydrates, proteins, and fats, their important constituent is carbon. Carbon is the important constituent behind. So behind any living organism, if you see any living organism, so any living organism, it has carbon. Okay. The number of products that are there inside the body, it's basically carbon. In the plants are also mostly carbon. They are products which are made up of carbon. Okay, so we see the importance of life to carbon. Like carbon is very important to life. It's available, all the plant body is carbon, all the human body is carbon, all the animal body is carbon. As the different nature, it arises because of proteins that are there. It arises because of fats which are there. And all of them, they are made up of carbon. So that is why we are studying about carbon. It has a number of products. A number of products are possible because of carbon. And no other element is there which can form a protein, which can form a carbohydrate, and which can form a fat. Okay. All these, they are the products of carbon only. So that is why we are here in the study of carbon. Okay. So, first of all, carbon is versatile. We have seen carbon is versatile, means it's available everywhere. There is no place on the earth where you will not find carbon. So it's versatile, it's available everywhere. Okay. So this is the versatile nature of carbon. It's available everywhere. And it has the property of catenation. It has an important property of catenation. That's Rilasya. Are you there? K. Subhacharvik, are you there? K. Subhacharvik, are you there?
Yes, sir.
So please turn on your camera. I shall
Yeah.
be able to see you. Okay. So see catenation. What is catenation? It is the self-linking property of carbon. So this property of self-linking, it is limited only to carbon. There is no other element. No other element in the complete periodic table. That means out of the 118 elements which are known, there is no other element which can perform the property of catenation, which means self-linking. Self-linking means one carbon atom can link itself to the other. This can link to other, it can link to other, it can link to other, and in this way, it can form long chains. There can be several long chains which are possible with the carbon. So this is possible only with carbon. There are no other elements which can form this, which can show this property of self-linking. They cannot link with themselves. Okay. If there is any, so that is your silicon, but that cannot form such bonds. Silicon, it can form bonds only up to 4. There can be maximum of 4 silicon in a chain, not more than that. Okay, so this is the property of carbon to form long chain bonds. That means there can be around thousands, millions of carbon in a single chain. So this is the property of carbon which separates carbon from other elements. Okay, its versatile nature, that is availability everywhere, and its catenation, that is the self-linking property of carbon, which makes it versatile. By which we see different number of products. So I hope you have understood these two properties of carbon. Now there is another property of carbon, that is it can show just okay. If you have heard about graphite and diamond, so graphite and diamond, both of them, they are 100% made up of carbon. Graphite is also completely carbon. Diamond is also completely carbon. Both of them are carbon, but they are having different physical state at the same temperature and conditions, same temperature and pressure. Okay. So here, two physical forms, two or more physical forms at same temperature, and pressure. So under similar conditions, we have two or more different physical forms. So this is the property that is available with carbon. Carbon can show the property that it can exist as graphite or it can exist as diamond. So can anyone name the property? What is the name of this property? The property by which a substance can exist in two or more physical form at the same time, at the same or similar conditions of temperature and pressure.
Allotropy.
Allotropy. Okay. So this is the allotropy of carbon. Is there any other element which can show allotropy?
Sulfur.
Any other element? Yes. Sulfur can show allotropy.
Phosphorus.
It has two allotropes, monoclinic sulfur and rhombic sulfur.
So can you repeat the definition?
It's written here, two or more physical form at same temperature and pressure. So if a substance exists in two or more physical forms at the similar conditions of temperature and pressure, we call them as allotropes. Okay. So sulfur can show allotropy. Dhanunjay, is there any other element which can show allotropy?
Maybe phosphorus.
Phosphorus, yes. Phosphorus also shows allotropy. It has two forms, yellow phosphorus and red phosphorus. So allotropy means there are two or more physical forms in which a substance can exist under the similar conditions of temperature and pressure. This is allotropy. Then if we move ahead in carbon, now we see the bonding in carbon. How the different bonds are made in carbon.
So
Yeah?
tin allotropy
Tin.
doesn't show.
Okay, tin. So is there anyone who can say allotropy of tin? Who knows allotropes of tin?
No idea, sir.
No ideas? Okay. Okay. Any other elements that you want to ask about? See, for tin also, the tin also shows allotropy. There are two allotropes of tin. So bonding in carbon, which type of bond will be formed? If you see carbon, it has 4 protons. In the center, it has 4 protons. Number of protons are 4. It has, 6 protons in the center. Okay. It has 6 protons. And in the outermost shell, if you observe the outermost shell, so it has
Electrons.
4 electrons. Okay. Now it has to satisfy its octet. What are the steps that are possible for satisfying the octet? How can carbon satisfy the octet? Octet means it should have 8 electrons in the outermost shell.
Yes, sir.
Tanishka?
Yes, sir.
How will the carbon just satisfy its octet?
So
It
by
has
either losing or gaining electrons.
okay by either by losing or gaining electrons. So when it is losing electron, so how many electrons does it have to lose?
4.
It will have to lose all the 4 electrons, and if it is gaining, so it has to gain 4 electrons,
4
right?
electrons. Yes, sir.
Then only its octet will get completed. If it loses 4 electrons, so there will be just 2 electrons in the K shell which will be fully filled. If it gains 4 electrons, then its L shell will be fully filled. Okay. So by losing, carbon will form like this. Carbon will be C4 minus, and it will have configuration will be just 2 KL, there will be just 2 electrons. If it is gaining electrons, so by gaining it will form C4 plus, and it should have KL, which will have 2 and 8 electrons. Okay. But none of them are possible. It's not easy for carbon to lose 4 electrons, and also it's not easy for carbon to gain 4 electrons. Okay, so it's not easy for carbon to lose out 4 electrons. If the carbon loses 4 electrons, so what will happen? If the
It will
carbon
be
is,
not easy for the protons to hold on to just.
see, if it is losing out the electrons, so consider from here each electron being removed. If this electron is removed, it would require some amount of energy to remove this electron. Next, we want to remove this electron, so more amount of energy will be required. If you want to remove after that the third one, so still more amount of energy will be required, as the forces of attraction between the nucleus and the electrons will increase. So the force of attraction between the nucleus and electrons, it will increase, and hence it will be difficult for us to remove the electrons from the outermost shell. It will not be easy to remove the electrons. So therefore, carbon cannot lose 4 electrons. This is not possible. So your first step of carbon losing 4 electrons, this is not possible. This is not possible of loss of 4 electrons. Okay. Why it's not possible? It would require larger energy or greater energy. It would require large energy for carbon to remove its electron. Now, suppose the carbon gains 4 electrons. If carbon gains 4 electrons, so the situation will be this K shell or L shell will be fully filled with 8 electrons. There will be repulsion between the electrons, and hence the electron will try to move away from each other. Okay, electrons will try to move away from each other, but there are only 6 neutrons in the nucleus. If carbon is gaining electron, so there are 6 protons and 10 electrons, almost double the number of protons. So it will not be easy for these 6 protons to hold 10 electrons. Okay. So hence, so we can observe here carbon cannot gain 4 electrons, as it is not easy for nucleus, with 4 protons, oh sorry, 6 protons to hold 10 electrons. If there are 6 protons, so it's not easy for them to hold on 10 electrons, right? So this is how carbon works. So how will this form the bond? it cannot lose out 4 electrons, it cannot gain 4 electrons. Okay, so the option which is left now, this system which we were looking, loss of electron, gain of electron, so such compounds which form bonds like this, they are called as the ionic compounds. It is the ionic compounds which form such bonds. Like if you see sodium chloride, so sodium chloride, it is an ionic compound. It has ionic bond between it. Sodium has lost 1 electron, chlorine has gained 1 electron, and hence sodium has become positive, chlorine has become negative. So there is a force of attraction between them, which is holding sodium and chlorine. So this is in the case of ionic compounds. You can have any other ionic compound. So ionic compounds, they are formed by the loss of electron and gain of electron. But here, carbon forms the bond by the sharing of electron, which are your covalent bonds. Okay. So carbon forms the bond by sharing of electron. It cannot donate electron, it cannot gain electron. So the option it has is covalent bond, that is sharing of electron. Okay. So sharing of electron means there is no complete transfer of electron, but the electrons which are available in the outermost shell, they are available for both the atoms which are involved or which are participating in the covalent. Like this, suppose we see the formation of ammonia, NH3. So your nitrogen has 5 electrons in the outermost shell. Okay. So nitrogen has 5 electrons in the outermost shell and it requires 3 electrons. So this nitrogen, it shares its three electrons with the 3 hydrogen like this. Okay. So here we are representing with the help of dot and cross. We are representing the number of electrons which are present in the outermost shell. Okay. So in the nitrogen, there are 5 electrons in the outermost shell, but in the hydrogen, there are only 1 electron in the outermost shell. Now, to form the bond, if hydrogen is sharing 1 electron with nitrogen, okay, so nitrogen will also share only 1 electron. So, from now onwards, this electron of nitrogen will belong to hydrogen also, and hence hydrogen is completing its octet. So in this way, this hydrogen will also bond like this. Here, this hydrogen will also bond like this. So we can see that the octet of hydrogen or the outermost shell of the hydrogen is fully filled. And in the similar way, the electrons which are belonging to hydrogen, they are now shared with nitrogen also. So nitrogen will have all these electrons with it. Okay. So if you see, now the nitrogen has 8 electrons. Is nitrogen having 8 electrons?
Yes.
Yes, sir.
Sir, I have a
Yes.
doubt.
Yes.
Sir, in what circumstances do electrons have to share?
What?
Do atoms have to share their electrons, and in what circumstances do they have to give out the electrons? Like, how
See.
is bonding and sharing of electrons different from giving out the electrons completely?
Okay.
Like, when is it?
See, the circumstances under which there are two things we look for. We look for ionization energy. Okay. We look for ionization energy and electron gain enthalpy. electron gain enthalpy, or there you can also talk of electronegativity. Okay. Here in ionization energy, you can also talk of electropositivity. Okay. So every atom, it wants to have a stable configuration. Okay. The stable configuration means octet, that it should have either fully filled, all the shells should be either fully filled, or it should have 8 electron in the outermost shell. This is the stable condition. Okay. So if an electron is having a less number of electrons, if an atom is having less number of electrons, like let's say sodium, so its configuration is 281. Okay. So there is just one electron in the outermost shell. So how much energy does this sodium require to donate this electron? It requires this electron to be lost to the surrounding, but at what cost of energy? There will be some energy which will be required for this electron to be removed from the outermost shell. Okay, and that energy we call as the ionization energy. Okay, so one consideration is the ionization energy, which tells us that whether it will donate electron or not. Okay. The second thing is that electronegativity of the combining atom. For example, if it is combining with chlorine, or is it combining with, let's say, iodine. Okay. So if you see out of this, chlorine is more electronegative than iodine. Chlorine can easily attract the shared pair of electron towards itself, whereas iodine is not able to do that. It also attracts, but it's not able to do that to the extent that chlorine is able to. Okay. And what defines this is the electron gain enthalpy. Enthalpy means energy. Electron gain energy. Okay. So everything what leads to this definition is the energy. Right? So I hope you have understood what are the factors that we look for.
Yes, sir.
Okay. Okay, so bye everyone. Good night. I'll be sending you some of the questions. Do solve them.
Yes, sir.
Okay.
Thank you,
Thank you,
sir.
sir.
Thank you, sir.
Nice, sir. Thank you.
Okay, bye.